Hello everyone, welcome to this video series, Introduction to Python. In this video, we would be covering what is binary search, the approach behind how this algorithm works, and how to implement binary search using Python programming language. As the name suggests, binary search is a searching algorithm for finding a specific value in an ordered collection. It can be used to search for an index or an element in a collection. Binary search can only be applied if the collection is sorted. If the collection is unordered, we need to sort it first before applying binary search. Binary search is an algorithm that divides the search space into two halves after every comparison. Binary search is a very popular and important searching algorithm. It's not too complicated, and you might have already seen various practical implementations of binary search in real life, like when searching for a word in an English dictionary. Remember, in a dictionary, all the words are sorted alphabetically. If you have to find a word master, for example, you could start from the first page and go through all the words until you find the required word. This would take a lot of time, as there are thousands of words in the dictionary. This approach is called sequential search. In this case, this is not optimal. Perhaps a better way to search would be to look at the word in the middle of the dictionary. Based on the character sequence, you decide to look either before or after the current word. Let us say you encounter the word lemon. Then you know all the words before this could not start with the letter M. The word master starts with letter M, so you need to look into the later half of the dictionary. You repeat this process of eliminating half of the words until you find the required word. Let us now look into how this approach works in Python programming language. Say we are given an array of integers as shown. We have to find index of item with value 10 in the array. In Python, arrays are indexed starting from 0 until length minus 1. We see the array is sorted in ascending order, so we can apply binary search. We need to first find the index of middle element in the array. To calculate the middle, you need to know the boundaries of the array. We initialize left with 0, the leftmost value of the array. And right would be equal to len of array minus 1. Len function returns the length of array. In this case, it would return 7, and right would be initialized to 7 minus 1, which is 6. Here, value of middle element is 12, which is greater than 10, the value to be searched. As 10 could not be on the right half of the array, we now only consider left half of the array as search space. We reset right to middle minus 1. Again, we recalculate middle element of the reduced search space. Now, value of middle item 4 is less than the value to be searched. We reset left to middle plus 1, as the value 10 cannot be on the left side of the search space, and we recalculate middle. As you see, the search space is again reduced by half. Now the value of middle is equal to the value to be searched. We can now return to the value of middle as the answer as we have found the value 10 in the array. One important thing to note here is, in case we had to search for 9 or 11, which is not present in the array, after reassignment in this step, the left index would have passed ahead of right. So we need to return -1 to indicate item is not present in the array. This is about the binary search algorithm in detail. Let us now write Python code for this approach using Jupyter Lab Notebook. This will further strengthen your understanding. So here we see we have a function binary search. It takes array, the array to be searched and item which is to be searched in the array as inputs. Array should be sorted, and item, if it exists, we return the index of item in the array. Otherwise, we return -1. So this is the expectation of the function. So here we initialize left equal to 0 and right equal to length of array -1. This is to set the left and right boundaries so that we can calculate the middle value. We loop until left has gone past right. So middle, we assign left plus right. This is floor division operator divided by 2. This ensures middle is always integer and we can use it as index of the array. Now, as a first step, we compare if the item in the middle of the array is equal to item to be searched. If it is true, then we return middle and target, whichever we are looking for has been found. And in case it's not equal and it is less than, then we ignore the right half. So item to be searched is less than whatever is the item in the middle. Otherwise, when item is to be searched is greater than the item in the array, we ignore the left half. So we assign left to middle plus 1. And if we have gone past the loop, then we return -1. That means there is no item found and target is not present. So to test this, I have written few test cases. So I'll execute them just to see whether they work. So here, I have used the same example which we have seen graphically for understanding the binary search approach. So here we are looking for item 10, which is present at index 2. So we will execute first the binary search function. It gets compiled, and then we'll run the scenario, which is the success scenario, a test case. So here we see that, okay, 10 is present at index 2. So we found in the array the item. And let's test the other scenario where we are looking for item which is equal to 11, which is not present in the array. So once we execute this, we see 11 is not present. So this is the expected result, because a result would have a value -1. As the binary search could not find the element, it will return -1 to indicate item is not present. So this is the implementation of binary search in Python. So hope you understood it well.